Hi, I'm James, a PhD student from the University of Adelaide, where I'm working closely with wheat breeders from Australian Grain Technologies to investigate how we can use various types of technology to collect and analyse data from large-scale field trials like this one. The main part of my work looks at how we can use sensors such as digital cameras and LiDAR, which is like radar but using light, to collect data from tens of thousands of field plots, and ultimately how we can use that data to help plant breeders select which of these plots could be the next variety for farmers to grow. To do this, we use a prototype imaging boom we've created, which is attached to a tractor and driven through these large field trials. As the tractor drives along, the cameras and LiDAR automatically capture photos and a laser scan of each individual plot in the trial. All of this data is being controlled and captured by a GPS unit and laptops in the tractor cab. Once we're down out in the field, we can grab that data out of the tractor and head back to the office to start processing it. The LiDAR data is processed using code written in the R language, while the photos are processed with the software called ImageJ. Once the data has been processed, we can measure basic traits such as canopy cover and canopy height, but we're also looking at using the LiDAR data to make 3D reconstructions of the canopy and measure more complex traits like crop biomass. So that's some pretty nifty data collection that we're doing. But what does that mean for breeders and researchers out in the field? Well, it means that we can start to replace these time-consuming and often subjective manual data collection methods with these quicker and more objective digital methods. There's also the potential to eliminate destructive sampling, which is generally too impractical to use within a plant breeding program. Most excitingly for plant breeders, instead of measuring a few trials in the breeding program, they'll be able to measure all of their trials and every plot within those trials. This will provide a really powerful data set for them to use, especially when it's combined with genetic and environmental data.